Good evening, everyone. Thank you so much for coming out. Excited to be here in Springfield tonight to talk about some front-end architecture and, whoops. Hold on. Sorry. Let's try that. Cool. So yeah, excited to talk about some front-end architecture and some of the our dependencies on front-end frameworks and maybe how we can look at those choices a little bit differently. So a little bit about me. My name is Hunter Trammell. I am a technical architect at One North. I work in the Adobe practice. So we partner with businesses and we help them with implementation, architecture, development, anything that involves technology. And so we go in there and help them build their systems and whatnot. One thing that comes up a lot, especially lately, is at some point or another, just like everybody, they decided to use a front-end framework in there for their website, and are currently having trouble meeting up with like modern requirements, as well as like basic things like performance and accessibility. So as new tools like AI and personalization are coming out, there's more of a need for kind of basic HTML, basic JavaScript, stuff like that, that the frameworks can't. Angular view for a website. We're then going to learn some things about how to kind of think like an architect, how to understand the requirements, the trade-offs, and so that we can use that to determine whether or not we actually need to use a SPA in our application. After that, we're going to look at some practical patterns and principles specific to kind of front-end development so that we can, as we implement our technologies that we've chosen, we can make sure that we're adhering to the architecture we've chosen. And then finally, we're going to take a look at how architecture touches us all in our daily lives. There will be some time for Q&A at the end, so if you do have any questions, I'd love to answer those if we have time. So, framework first thinking. The framework first thinking, to me, is the just automatic, like, if I'm going to build a website, show of hands, how many of you are going to default to using a JavaScript framework, regardless of how to solve the problem, just because it's cool? I do the same thing, right? But because this trend of devs wanting to use a SPA for everything, we're starting to see a lot of issues that stem from this. So just kind of take a step back at why we use frameworks. If you think about when jQuery was introduced, it provided a way to kind of handle the interactions between JavaScript and HTML. Just a nice little sprinkle of syntax on top of JavaScript. Perfect, right? And then as that started to get more used, more solutions to the problem came along, we ended up with Angular, which kind of took it a step further and added directives and HTML templating and kind of bridged the JavaScript and HTML together. And then continuing on that, as that problem, Angular was used, jQuery was used, a new way to do things came out, and which is kind of where we're at now with the more modern, like compiler-based frameworks, right? So instead of using HTML and JavaScript, we're now kind of defaulting to doing all of our HTML inside JavaScript. So I think that at this day and age, there's kind of two issues with that JavaScript HTML strategy, I suppose. So the user requirements have changed since the original problem of having that reactivity in the HTML and JavaScript was found, right? So our requirements are changing. Things are starting to be a lot more focused on the actual user. So we're needing to implement things like personalization so that companies can dynamically swap content based on who's actually looking at their website, or using some sort of AI to enhance the content, that sort of thing. So a lot of this stuff needs to happen before the page loads, or it could kind of hinder the user experience a bit. The second thing that's happened is the native technologies. Those have also continued to progress. While we're solving these problems, the native technologies are also growing immensely. And we're at a point now where, if you were to say, hey, I need you to build a website 5 years ago, if you didn't do it without a framework, you probably would have stormed out of the room and, cried. But given how far that the native web technologies have coming with all the JavaScript APIs and whatnot, it's not really as bad, right? If you have to build a slideshow, do you need to throw a slider dependency on there, or can you just use something like the intersection observer API to resolve that? So more and more companies are kind of coming to terms with this reliance on spas in their front end, where everything kind of takes the characteristic of the technology they're using. Whoops, my clicker was not connected. Okay. So here comes the main problem. The tool is driving the solution. So we've become accustomed to using JavaScript frameworks by default, and we're not necessarily using JavaScript frameworks because they're the best solution. So a little example, several years ago, I was working for a smaller marketing agency. I was the only developer, really the only technical person, so I kind of wore all the technical hats or whatever, so I made a lot of technical decisions. Now, whether or not I should have made a lot of those decisions is, learning, but we primarily built websites, just like WordPress websites for clients, and it came time to where the company itself was like, hey, we need to redo our own personal website. And so I got super excited because it was about the same time that Jamstack was really taking off, and everybody was like, headless, headless, headless. And so, of course, I said the same thing and decided to build a headless WordPress with Vue front end, static generation, super cool. It worked, it was fast, but then, fast forward several months, I'm leaving the company to do something else, and now they have a problem. So I built that using the latest technologies. It's a great website, but the only contractors they had access to were PHP developers. And while they could make some updates to their website, because it was headless, it was restricted a little bit on if they wanted to add a completely new page or a new template, they would need some sort of developer intervention. So by choosing that tool, even though it was able to deliver the product we wanted, in the end, it had a side effect of not being super maintainable because they just didn't have access to the developers who knew how to work on JavaScript. So as front-end systems kind of grow in complexity, this need for thoughtful architecture is kind of growing. So JavaScript frameworks as a whole, I feel like they've kind of grown into this quasi-architecture where we know React isn't an architecture, but when we create an app with React, we end up doing a lot of things the React way, right? And it kind of ends up taking on a lot of the characteristics as a normal architecture, but then we're just kind of siloed into this one technology, and unless we anticipated all of our future requirements, we're kind of stuck with the implementation. So this is going to lead to things growing out of control. Your architecture is being influenced by one technology. And so we kind of need to take a step back and check our habits. That default reaction of, I need a spa, we're not going to build a website without a framework. So how do we solve this? How do we keep ourselves from choosing the coolest tool or the newest framework, right? We just take it back to some architectural basics. We need to make sure that we have a clear understanding of the domain as well as the other requirements. So are we building a marketing website that's like brochureware, or are we building a dashboard for data visualization? So if I were to pitch React for one of those two, I think it would be a clear choice on the data visualization that would need the actual React versus brochureware, which is just static content. Second, we need to make sure that we're learning about and staying informed different patterns and principles related to architecture in the front end. And then lastly, we have to make sure that we're prioritizing the problem itself. So we're not allowing our tool to drive our solution. The requirements in the domain are driving the decision, not the technology. So if any of you guys are thinking that I'm just saying React is bad, don't use frameworks, that's not what I'm saying. I apologize if it came off that way. I'm just advocating for more thought behind the inclusion of these tools because it can create constraints later. So now that we've kind of taken a look at the problem with framework first thinking, how do we think like an architect to kind of prevent these situations from happening in the future and to make sure that we're making informed choices? So we all share a role in architecture. Even if you don't necessarily have the title architect in your role, as a software engineer, you share a responsibility to make sure that the architecture is maintained and it isn't diverging into something else, especially if you are the senior most developer or, in my case, the only developer at the company. So while we're creating software, we're constantly making these tiny decisions, and if they're not kept in check, then things will grow bad. And even something as small as like adding a dependency or deciding how much error handling to put in a function. So we solve the problem by understanding the requirements. So we have 4 kind of general categories for requirements to fall in. We have our technical requirements. These are the concrete, super implementation specific rules that are going to dictate what the system has to do. So we have to use TypeScript, or we have to use the SSR capability that exists in the CMS. We also have non-technical requirements, and these are requirements that revolve around business or organizational constraints, such as we have to use React because nobody on our team knows any other framework, or we have to make sure we are passing web accessibility at a AA level because we're nice people and we don't want to get sued. And then we have domain, which is more specific to the actual functionality that the business or industry, specific to the functionality or the business that you're building for, right? So if you're building an e-commerce platform, you might have a domain requirement that you'd be able to support n number of SKUs or have some sort of cart system. And it even could be something like with healthcare or finance that you have to make sure that you're respecting data retention, or none of your forms are transmitting PII data, stuff like that. And then our last category is more of a grouping of concerns that are going to kind of influence your architecture for the long term. So things like performance. If I'm building a site and I have a performance requirement, it should be less than 2 seconds for the least contentful paint, or even scalability. If I want to add a feature, I shouldn't have to restructure the entire application or do any refactoring. I should be able to just add it in. So architecture happens at every level of development. Even if you're not implementing something brand new, like I said, those tiny decisions that you make are affecting the architecture as a whole. So those requirements need to constantly be assessed and kind of kept back of mind so that it can kind of guide the creation of your software instead of letting the tool play that out. So we understand how to look at requirements, but not every requirement is going to be met. There's going to be times when you have conflicts and you need to make a trade-off or have some sort of requirement that's going to need to take priority over another one. So how do you choose the answer when there's no clear winner? Well, your first step is to identify and categorize your requirements. In a perfect world, your project manager would hand you a piece of paper with your technical requirements, non-technical requirements, utilities, all that fun stuff. That's not real life. So you're going to kind of need to break down the requirements yourself. If you know that your team is only capable of supporting X technology, well, you need to make sure that you identify that requirement of only supporting that technology. Using something like a decision framework to measure things like impact versus effort or benefit versus risk. And then lastly, letting the business and the user impact drive the solution to determine the best path forward. So if you have been given a task of creating a like an internal dashboard, right? It's not customer facing, it's for internal employees. You've got 5 weeks to do it, and you need to make the decision on whether or not you need, are you gonna build a new design system of components to use to build this application, or are you gonna use something like Material UI that already has all those components? Since you have a shorter time scale, and since it's an internal tool, you don't necessarily need to have a pixel perfect brand representation. So using something like Material UI would be a good example of a, an acceptable trade-off in that scenario. So there's trade-offs in every decision. The pros and cons should always be weighed thoughtfully, and understanding why is always, always, always more important than understanding how. So when you're going through these decisions, you're probably going to have a lot of kind of thoughts, and having to explain to every person every single step of the way how you came up with that decision. It's not something you're just going to remember off the top of your head. So you can use something like an ADR, which is an architectural decision record or review. That's basically just like a formal document that will highlight all of that decision-making process. So you start off with your problem, and then you write out your proposed solution, alternative solutions, and then ultimately why you chose the proposed solution over the others. So that way, if you leave the company or 5 years down the line, you're like, hey, who the heck chose this technology? You have something to look back on and have a justification for why that change in your business exists. So as far as we understand how to identify that the thought process needs to go behind using these frameworks, we also know how to make the decision and prioritize and trade off. But what about for implementation? So when we're ready to actually execute the technology, what sort of front-end architectural principles and patterns should we make sure that we're following so that we can keep things good to go? So modularity is very important in the front end, breaking things into smaller reusable units. So this could be components, this could be services. It's going to make things a lot easier to test, to deploy and reuse, because they're smaller, they're isolated, and they're not interconnected between a bunch of different things. This is also going to make sure that your system stays nice and loosely coupled. Second principle is going to be separation of concerns. This one kind of piggybacks off modularity a little bit, but more of takes into account more of a grouping perspective. So creating clear separations or partitions in your application logic, structure, styling. If you think about like a layered architecture, like an MVC, you have that clear difference between your view layer, your controller, and your models, so that there's no interweaving between the different aspects of your application. Next is reusability and composability. So when you're building components, and again, these can be UI components or services, like different pieces of your system, they should be usable in multiple contexts. The components should be agnostic enough to be placed in really any instance and perform properly. This is going to help reduce your duplicate code, and it's also going to help maintain consistency with your design. And then we have simplicity. Simplicity is going to make sure that you're prioritizing systems that are easy to understand and modify. I don't know if anyone in here is, I love to code, right? And sometimes I'll get a little carried away and I'll do something wild in a PR and it'll get closed down, not necessarily because it doesn't work, but because it just doesn't make sense, right? So using like a bitwise operator to evaluate whether or not an array has something, cool, but not necessarily readable by everyone else, right? So keeping your code simple is going to prevent developer confusion. It's going to prevent things from being misinterpreted. And it also is going to help reduce your bugs and deployment time. So we've looked at a couple principles. So what about some patterns? So patterns are going to take all those principles and provide kind of a blueprint for you to apply to your application. So event-driven architecture is my favorite one to use in the front end, just because it keeps things nice and decoupled, because every component, service or whatever, they're not talking directly to each other. They're speaking with a proxy, an event bus, that's going to handle the communication between elements. They don't care who's listening to them. They don't care if somebody else says something. They just do what they're told, or listen to be told to do something. And this also reflects real behavior in the browser. So like if you think about just something as simple as like the JavaScript event API. If I click a button, I can bind an event listener to that button. The button doesn't care how many event listeners are on it. It doesn't have any, it doesn't care what happens when it's clicked. It just knows I am to be clicked. If somebody clicks me, great. That event listener is, where the actual magic happens. So this architecture's kind of mimicking the, default behavior that already exists in the browser. And lastly, it makes collaboration super smooth. So as you're building out your application, because you're using this event bus, it's very easy to mock and test different parts of your application without needing other parts of it to be completely finished, right? You can have, multiple teams working in parallel, because as long as you know, what event channels and topics to listen to, that's all you need. And then our last pattern is atomic design. So if you're familiar with design systems and more of the artsy side of development, you might have heard of atomic design. Brad Frost introduced it, and it's basically a design framework that uses modularity. So it's based on building blocks. So each, if you take a page, right? A page has components, different aspects of it, and you're going to break it down into the smallest reusable block, an atom. So you're going to look at those smaller blocks, and then you can decide to include those atoms together to create a slightly larger block, right? So an atom could be a button or a piece of text or an image. Those individual blocks could be used across various components, various combinations. So having those atoms defined, and then later using those to, composing those into larger units is going to help a lot. And then lastly, maintaining that structure across the application, whether it's just the file system or for actual services and UI components. Atomic design in itself is more focused on component, but the same principles can really be applied to anything in as you're setting up your project for a front-end development. So we understand that architecture is something that is constantly happening. We're all involved in it. So how does that fit into our daily lives? Like how do we practice architecture as a daily habit? So the first thing is just choosing the right technology, right? So we've learned that we need to understand our requirements. We don't let our tool drive the solution. So we're going to define our problem and understand those requirements, and then based off that, we're going to choose a technology that is the best fit from a solution perspective, not just because it's sexy. And then lastly, we're going to design the system, and then we're going to supplement it with tools so that we can build the stack around the architecture and not let the stack define the architecture itself. Managing dependencies, this is a huge one. Every developer should be somewhat aware of the risk of adding a dependency to a project, whether it be just from a performance standpoint of adding that extra code to the browser, or even a security standpoint. And a lot of been seeing a lot lately of old packages that have some like infinitely nested dependency that somebody slips some malware into, and because it's a dependency of a dependency of a dependency of a dependency, until somebody actually finds it, it's pretty hidden. So evaluate with intent, right? Every dependency should be evaluated because it is going to add complexity to your project. So ask yourself, does this solve the problem, or is it just let me do a little bit less typing, right? Look for a solution with native technologies. So again, back to the slideshow. Like, do we really need an entire NPM package to put a slideshow on the page, or could we use a JavaScript API to handle that for us? Second, abstract your dependencies. If you're adding a dependency to your project, take some time and wrap it up. So don't use it directly within your code. Give it a little safety net, right? So that if you need to remove it or replace it down the line, you're not going to have to modify a bunch of systems. You just need to unplug this one part. And then lastly, reassess regularly, right? As much as we like to think, packages are not set it and forget it. So it's important to make sure that you are aware of what's currently installed, and you're reviewing those things to make sure that package X and package Y are still valid and fall under the requirements of your application. So I'll say it again. Architecture is for everybody. We are all architects. Everybody has a responsibility to empower the architecture and make the right decisions. So if you take anything away from kind of what we've gone through, the biggest thing, these 4 points is what I want you to go home with. Every developer is an architect. I guess I don't need to say that for the 12th time, but it's important to prioritize intentionality over habit. So, revisiting your habitual tools like JavaScript frameworks, and make sure that you're not just adding it in there because it's what you're used to, or it's what some person on Twitter did. Make sure that it truly solves a problem within your application, and it's not just there because it's awesome. Third, principles first, right? So when you're not sure if the decision you're making is the right one, go back to the core principles. Does this decision enforce modularity? Does this decision enforce simplicity? Me adding this in here, is this going to affect our ability to meet accessibility or performance requirements? And then lastly, adapt and learn. As I'm sure every single person in here is aware, and honestly probably why you're all sitting in seats, is that architecture, like software development, is an evolving discipline. You need to constantly be aware of trends and exposing yourself to different ways of thinking so that you can be ready to act as those requirements change, because they're not always going to stay the same. So that is front-end architecture.
All right, if we got any questions, I can bring the mic around. All right.
Hi. Where would you recommend for new developers to start learning more about architecture?
Great question. So there's books is going to be your best bet. Architecture is kind of one of those weird things where everybody has a different interpretation of it. There's a book, I think it's either Fundamentals or Foundational Software Architecture by Neil Ford? Tom Ford? Not Tom Ford, that's glasses. Neil Ford. That one's excellent. I recently revisited that one because it has a lot of stuff on like soft skills, which is super helpful as a developer. And then also there's all the old like Uncle Bob books, like Clean Code, Clean Architecture. Those are good. A little bit outdated, but the main messages are still pretty relevant.
Hello.
was going to ask, given that the technology is always changing around us, you yourself gave a timeline of how things have changed under our feet already, how would you know this is suited to this is better for that? How would you pick between your components, given that you yourself can give us a flow chart as to what we should pick in any given situation? Seems like that's the big challenge.
Yeah. And unfortunately, the answer is there's no one-size-fits-all problem. You know, every problem is going to have a different set of requirements attached to it. So at the end, it just comes down to you know, managing those trade-offs, making sure that the technology that you've chosen is the best possible fit based on the requirements that you have at this point.
I'm just curious, have you come across a scenario where you did have to migrate an application fully off of a particular popular framework because it caused issues?
Yes.
And how was that experience?
Yes. So the migration part wasn't terrible because we got to kind of start from scratch. We didn't have to like fiddle with anything that had already been built outside of like, you know, migrating content over. So I can't say exactly what client, but it was a large telco company. They used Angular as their front end, and we redid it, took out all the Angular, just used static HTML from the CMS. But then in order to provide some of the extra utility, we used a framework called Alpine.js, which is very similar to like early Angular, where you're just using directives in your HTML. There's no compiler needed. It's as close to JavaScript as you can get without being JavaScript. And I'm trying to think of what the actual stats were, but the actual like performance scores of the Angular app versus this new one that was completely just, you know, plain HTML with some JavaScript sprinkled on. It was pretty drastic difference. To the point where even Google published a study on, you know, that migration specifically around performance and whatnot.
If you've gotten pretty deep into a project and then you've discovered that possibly there are more efficient methods you could be using or more streamlined approaches, where would you find the balance between taking the time to implement those approaches versus taking the time to continue updates and continue adding features?
Yeah, that's a good question. So I think that kind of comes down to a couple things, right? So that's why, you know, obviously hindsight is 20/20, but that's why it's super important to make sure that you have a very, very thorough understanding of all the different requirements, you know, technical, non-technical, that sort of thing. But if you do get to a point where, you know, you've gone this far and you're starting to, you know, hit a roadblock in your proposed architecture, or you know, requirements change last minute, you kind of just you're going to have to kind of look at the, you know, the remaining requirements. Like, do you have the time to redo things, or you're just going to kind of have to get creative in that space. It's hard to like give specific like do this, do that, because it's very hard to do that with architecture, just because there's so many you know, different variables that go into how it's built. It's really just dependent on the actual, you know, business use case requirements and stuff like that.
Thank you so much for presenting tonight. So whenever you're dealing with like a little bit larger team sizes or less independent projects, one of the things, I know you weren't really preaching against frameworks, but really just being very cognizant of your choices in the matter. How do you reconcile the idea that like you've got a little bit of a looser structure whenever you're not in like the React mindset, as you put it? There's more wiggle room, which potentially means like longer stand-up style conversations about how to do what you're doing. Like, how do you find the balance there, I guess?
Yeah, and that's kind of where like architectural patterns and whatnot comes in, right? So if you decide that you're not going to be doing React, you know, using something like a layered architecture where you have your you know, all of your business logic is separated outside of your, you know, your view logic. You know, your components might have you know, a small bit of JavaScript or whatever that's kind of bound to them that, you know, specifically will just you know, publish or subscribe to different things, right? So that's about the extent of what your actual like component logic would look like, and then everything else would be you know, pushed out into a different layer and kind of structured from there. Did that answer it? I don't know if I hit that on the head.
I was kind of talking in a different direction, but it's good, like, general advice, yeah.
Okay.
Thank you.
Any other questions? Going once, twice. Let's give another round of applause to Hunter, please.